will be minus NP by OP. Finally, cos of 90 degree plus theta will be equal to minus sin theta in the third quadrant. Now we see from this triangle ON by OP, that means base by hypotenuse, that will be equal to cosine theta. Finally, sine of 90 degree plus theta will be equal to cosine theta. We can show similarly cosec 90 degree plus theta will be equal to sec theta. You see, we are finding trigonometrical ratios of 90 degree plus theta with respect to the angle theta of the original triangle ONP, which is drawn within the first quadrant. Next, tan of 90 degree plus theta, base by hypotenuse, perpendicular by base, N1 P1 by ON1, N1 P1 ON by ON1, that is equal to N1 P1 perpendicular by base, N1 P1, that is equal to ON by ON1. Therefore, actually, earlier I found tan ratio first. Serially, we have to find cos ratio, then sec, then tan and cot. Now, cosine of 90 degree plus theta, that will be equal to ON1 base by hypotenuse OP1. Now, ON1, that will be equal to in length NP, but as per sign convention, it will be minus NP by OP. Finally, cos of 90 degree plus theta will be equal to minus sin theta. Similarly, we can find sec of 90 degree plus theta, that will be equal to minus cosec theta. Then tan 90 degree plus theta from geometry we have found that will be equal to N1 P1 by ON1, and after calculation it will be minus cot theta. Then cot of 90 degree plus theta, that is similarly minus tan theta. Thus, we have found trigonometrical ratios of 90 degree plus theta. Remember, in all cases we have considered with respect to the original triangle ONP. Thus, we have found trigonometrical ratios of negative angles as well as trigonometrical ratios of 90 degree plus theta angle. Now, we shall move to find the trigonometrical ratios of 180 degree minus theta. For that, we need a diagram. Next, we move to find the trigonometrical ratios of 180 degree minus theta. For that, I have drawn the necessary diagrams. You see, OX1, that is the next position of the revolving ray, so that angle X OX1 equal to theta. Then the revolving day rotates to the position OX dash, so that angle formed will be 180 degree minus 180 degree. Then it comes back to the angle theta and comes to the final position OX2, so that angle XOX2 will be equal to 180 degree minus theta. Now, the trigonometrical ratio of 180 degree minus theta will be same as that of the angle N1OP1. Now, by calculation, we can find that angle N1OP1, that is by the description also, theta. Now we take a point P on x1 and P1 on OX2, such that OP will be equal to OP. Now we draw perpendiculars from the points P and P1 on the x-axis, which are Pn and P1N1. Now we can show easily the congruency of the triangle ONP and ON1P1. From the congruency, we find lengths of ON1 and ON will be equal, but by sign convention, ON1 will be equal to minus ON and N1P1 will be equal to NP. Now, let us calculate the trigonometrical ratios. Sine 180 degree minus theta, that will be equal to sine of angle N1 PO. Perpendicular by hypotenuse, perpendicular is N1 P1 OP1. N1 P1 already we have got NP by OP. Now, if we consider this triangle NP by OP, perpendicular by hypotenuse, therefore sine 180 degree minus theta, that is equal to sine. Similarly, we can find cosec 180 degree minus theta, that will be equal to cosec theta. Number 2, cosine 180 degree minus theta, that is equal to ON1 by OP1, ON1 minus ON by OP. Therefore, cosine 180 degree minus theta will be equal to ON by OP minus cos theta. Similarly, sec 180 degree minus theta will be equal to minus sec theta. Then tan 180 degree minus theta, N1 P1 by ON1, N1 P1 NP minus ON. Therefore, tan 180 degree minus theta will be equal to minus tan theta. Similarly, cotangent 180 degree minus theta will be equal to minus cot theta. Thus, we have found the trigonometrical ratios of 180 degree minus theta. Initially, we take theta that will lie in between Thus, from starting, we have found trigonometrical ratios of negative angles, then trigonometrical ratios of 90 degree plus theta, then trigonometrical ratio of 180 degree minus theta. Proceeding in this way, we can find also trigonometrical ratios of 180 degree plus theta, then 360 degree minus theta, 360 degree plus theta, etc. And now let us sum up the things already we have found. Trigonometrical ratios of the positive acute angles will be positive, and that is indicated by all. In the first quadrant, I have mentioned all. That means all trigonometrical ratios will be of positive sign. Then we have deduced that trigonometrical ratio of sine and cosec will be positive when the terminal position of the revolving ray is within the second quadrant. That means trigonometrical ratio of sine and cosec. Just we mention here sine because cosec is reciprocal of sine. Then in second quadrant, sine ratio will be positive. Then tan ratio will be positive in the third quadrant, and cos ratio, cos well as sec will be positive in the fourth quadrant. Thus we get the so-called all sine tan cos rule. I repeat, all positive, all trigonometrical ratios are positive when the angle be positive acute. Trigonometrical ratio sine when the angle will be in the second quadrant will be positive. Trigonometrical ratio of tangent when the angle is within the second and within third quadrant. Then trigonometrical ratio of cosine when the angle is within the fourth quadrant will be positive. Thus we get all sine tan cos rule.